Any component, no matter how simple or complex it is normally has to transmit or sustain certain kind of mechanical load. There are mainly three kinds of mechanical load that any component would normally could go through. Number one, dead load. Number two, live load. And number three is sudden impact load. Now, dead load is a load where it is only applied once and it stays there for a long time. To give you some examples of this load, you can look at the walls or the floor or the ceiling. They are the examples of some dead load. Now, live loads. So live loads are those where the load varies time to time. For example, if you are walking down on a bridge, you will see the load will be changing or load will be varying based on how many vehicles are there on at that moment. Or sometimes when you go and see max 200 people capacity or max 5 vehicles on the bridge, that is when they decide on that particular component they require, that is the max load of that bridge, or that is the max load of that component. And the third one is the shock load. So shock load is something that is applied all of a sudden. For example, when two vehicles are involved in a crash, or another example would be when you're putting a nail through a wall and using a hammer to punch it, that gives a sudden load to the nail, which is why it is going more and more into the wall. To understand how this load impact the mechanical component, we actually need to understand how the mechanical component is made of, or what is the atomic structure of that mechanical component. I will explain you how the whole thing works later in this video, but so now you know what load is. Let's understand the stress and strain in the system. When a certain load is applied, any component, no matter what, it goes under a certain deformation. It does not matter how strong material is or how small a load has been applied to, it always goes under a deformation. So based on the metal and the amount of load applied, it will go under deformation, and the deformation will vary based on the type of material and type of the load that has been applied. If this deformation disappears after you have taken off the load, or if you have removed the load, it's called elastic deformation. But because of that load, if the metal or component goes into a permanent deformation, that means it does not change the shape or it stays in the deformed shape, it is called plastic deformation. Now, this deformation is measured by the term called strain. When you apply load to a component, it affects the atomic structure of the component, even though the atoms are round. But when they come together, it does create a certain shape or certain patterns into the metal structure. So this pattern and this structure is explained very nicely in this video that I'm showing you right now. So to explain you the metal structure, in this video, and they have put a lot of small metal ball into a wall-like structure. Even though they are round, they still create a certain pattern, which gets affected when load or heat is applied. These atoms are actually connected to each other with the metallic bond. So stress is nothing but a resistance to deformation which we apply through load. So this resistance to deformation is actually called the stress. Because of the metallic bond present in the structure, they obviously resist the external force. So this resistance is measured in a term called stress. Now, based on the applied stress, we understand how the material will behave under the load. Or there are mainly three types of applied stress. One, tensile stress, two, compressive stress, and the third is shear stress. So tensile stress is a stress when we try to understand how stronger material will hold to each other using the metallic bond when we try to pull the material apart using equal and opposite force on the structure. Compressive stress is completely opposite to tensile stress in that we try to put pressure from both sides in equal and opposite direction to see how much the metallic bonds between them can be compressed. In this, also we apply the same force in the opposite side, but not against each other, but towards each other. Now, the third type of stress is a different kind. It is known as shear stress. Shear stress is where we try to slide a layer of metal or layer of metallic bond between two layers, and it is normally applied side by side or in the direction of the plane to see how the material or how strong the material is if we want to slide the material and take them apart or crack the material apart. To give you an example, a simple example of this is your kitchen. When you are chopping off the vegetables, try to chop vegetable using applying the straight force or applying a slicing force. You will normally notice that when you apply a slicing force, it is very easy to cut or chop the vegetables. And that is one of the good example of shear stress. Thank you very much guys for watching. Please like, share and subscribe. I will see you in my next video in which I'm going to explain all these different type of material behavior and how they behave under different type of stress.